Hello. Let's start working on an Arduino project that will help us grasp both variables and the const concept in this lesson. The circuit schematic drawn with the Tinkercad application and the written code are visible on the screen. To keep the video concise, we'll proceed with the lesson using prepared circuit diagrams and code. We have connected the ground line from the Arduino to the negative horizontal rail of the breadboard. Arduino pins 4, 5, 6, and 7 will be employed to achieve the blinking effect for 4 LEDs. We connected the yellow LED to the fourth digital output of the Arduino using a yellow cable. The blue connection cable is attached to the fifth pin of the Arduino, controlling the blue LED. The green LED is connected to the sixth pin, and the red LED is connected to the seventh pin. We performed variable declarations in the upper part of our code to specify the digital output pins to which these LEDs are connected. The type of our variables is integer, and we define them as constants because the values of these variables will never change within the program. We perform this variable declaration at the top of our code so that it is valid both within the setup and loop blocks. Our first variable is the value of the yellow LED, which is 4, because yellow LED is connected to pin 4. The value of the blue LED variable is 5 because it is connected to pin 5, while the green LED variable is 6 and the red LED variable is 7. Now we organize our pin modes in the setup section. Using the pinMode command, we specified that our 4 digital points corresponding to yellow, blue, green, and red would be utilized as outputs, with the yellow LED represented by pin 4, the blue LED by pin 5, the green LED by pin 6, and the red LED by pin 7. Although we could have directly used 4, 5, 6, and 7 here instead of variables without any issues, our purpose is to enhance clarity by easily identifying which LED is connected to which digital output through the use of variables. Upon examining the loop section, the initial action observed is the provision of power to the yellow LED via the digitalWrite command. Subsequently, we ensure that the blue, green, and red LEDs also receive power, followed by a delay of 1000 milliseconds to keep the LEDs illuminated for 1 second. Afterwards, we use the digitalWrite command again to turn off these 4 LEDs, followed by a 1-second delay once they are turned off. With our program located in the loop block, it will persistently run as long as the Arduino remains powered, resulting in an unending cycle of blinking. We'll observe the circuit within the Tinkercad application. When we start the simulation, we can observe that the LEDs blink at 1-second intervals. 4 LEDs blink synchronously, switching on for 1 second and off for 1 second. When we physically set up the circuit and upload the code from the Arduino IDE program, we can achieve the same results. Wishing you a productive time until our next class.